Assalamualaikum warahmatullahi wabarakatuh, Doctor, and to all my friends. My name is Nurul Hasanah binti Muhammad Yusof, and my matrix number CE190037. Okay, introduction for this assignment. A conveyor is a mechanical device that transports goods to use. These are found in a variety of industrial plants and are utilized to transfer bulk materials or unit goods through the manufacturing process. Conveyor applications use a basic speed control method in which the drive simply maintains a constant operating speed that can be altered at any moment. To transfer goods, a conveyor system may use as many parts to make easy to us. That's all. Thank you.
Assalamualaikum warahmatullahi wabarakatuh and a very good morning. My name is Muhammad Fatul Norman bin Muhammad Azizuddin and my matric card number is CE190244. So for today, I would like to present our manual calculation for sketch the corresponding magnitude and phase asymptote. So what we need to do first of all, we need to assume a random operator transfer function GS. So our GS is 1.45 over S bracket 1 plus 0.05 S bracket 1 plus 0.1 plus 0.1 S. So the next step, what we need to do is if we want to plot a plot diagram for magnitude plot and phase plot, we must use this calculation or this technique. So what we need to do first of all, we know that our GS is 1.45 over S, 1 plus 0.1 S, 1 plus 0.05 S. So what we need to do is we take out the 0.1 and 0.05 S over here and times it. And then for the S over here, so we know that S bracket S power of 2 plus 20S plus 10S plus 200, if we get S power of 3 plus 30S power of 2 plus 200S. So over here we will write S bracket S and then bracket S plus 10 and then bracket S plus 20. So to get the 290, 1.45 divided by the value of multiplication of 0.1 multiplied by 0.05. So we get 290 over here and divided by S plus 10, S plus 20. So next what we need to do is we replace the S with J omega into the equation. So we will get 290 over J omega bracket J omega plus 10 and then bracket J omega plus 20. So to find the magnitude of J omega, to find the magnitude of J omega, what we need to do is the formula is 290 divided by omega square root omega power of 2 plus 100 times square root omega power of 2 plus 200. And then to convert the value of the magnitude in the decimal, we just use this formula 20 log 10 and the value of magnitude in decimal. So to find the phase of our magnitude, what we need to do is the formula is negative 90 minus tan negative 4 of 1 times omega divided by 10 minus tan negative 4 of 1 omega divided by 20, and the unit is in degree. So we can calculate the value of magnitude and phase for a different value of omega. So this is a different value of omega, and over here is the calculation on how we want to get the G in decimal and the phase. So we just use back the formula that I have tell up here and then put the omega value into it. So then for the graph for magnitude, we will get like this. We will go to negative side, and for the phase angle, we will get like this, from negative 90 to negative 270. So we know that the system is stable because gain margin is less than phase margin, and both are positive. So this is the graph for magnitude, and this is the graph for phase. Okay, so that's all for my part. Thank you.
A very good evening to our doctor and to all my friends. Today I am going to talk about group assignment, which is on industrial application transfer function, and I am going to explain on the part of graph and the simulation. Before we see the graph and the simulation, we need to know the calculation before we doing the simulation. Okay, this is a table that we are going to use for our simulation and the graph. Here is our gain value, omega, magnitude, and also phase angle. Okay, this is our gain, magnitude, and phase angle. Before we plot the graph, we need to know the maximum and the minimum value. Our minimum value that I assume is 16 because we get 70.21, and our maximum value I assume as 70 because we get 70.96. By using or by phase, based on the magnitude and the phase angle, we are going to plot a graph. Here is our magnitude graph and also our phase angle graph. Now let's look on our simulation. We know that the system is stable because gain margin is less than phase margin, and both are positive. Now let's look on the simulation that we construct. This is a simulation that we construct. Okay, our magnitude of gain J omega is 290 as in the calculation, and our phase plot that we get in the calculation is 130 and 200. Now let's look on the simulation and the result. Here is the result that we get for magnitude and also phase angle, and we know that the simulation graph is accurate with our manual graph that we plot for magnitude and phase angle. That's all from me. Thank you.
Assalamualaikum and hi. My name is Muhammad Aslam bin Mat Asri, and my matric number is CE190007, and I from group 8. For the conclusion for this project is the first is we can make more understand when do this assignment, and the second is we can make comparison when do manual calculation and simulation using MATLAB software, and the third is student know how to use MATLAB software to get the result and know how to sketch the corresponding magnitude and phase asymptotic board, and the fourth is last but not least efforts to create collaboration between group members completing assigned tasks.